300 artisans. One production line, zero compromises. Welcome to the only place on Earth where a 503 horsepower beast gets hand-assembled alongside your neighbor's plug-in hybrid commuter, and both roll out perfection every 54 seconds. This is BMW Group Plant Munich, and what happens here breaks every rule of modern mass production. While Tesla robots stamp out identical electric sedans and Ford's assembly lines churn out F-150s by the thousands, BMW engineers orchestrate something borderline insane, building the fire-breathing M3 Competition, the practical 330i sedan, the eco-friendly 330e plug-in hybrid, and the versatile 3 Series Touring on the exact same assembly line using the same robotic systems with the same workforce. And here's the kicker. They do it while maintaining handcrafted traditions that date back 35 years to the legendary E30 M3. Today, you're getting an all-access pass to one of the automotive world's most closely guarded secrets. How BMW builds a modern performance icon that balances Munich craftsmanship with German efficiency. We're talking hand-formed body panels, carbon fiber roofs adapted from supercar production, seats that take 3 hours to craft, and an engine assembly process so precise it makes Swiss watchmakers jealous. Buckle up! This is going to be extraordinary. 35 years of evolution, one relentless pursuit. Before we step onto that factory floor, let's rewind to 1986. The original BMW M3 E30 roared into existence as a homologation special. Basically, BMW's ticket to dominate touring car racing. The rulebook demanded 5,000 street-legal copies. BMW built nearly 17,000 because demand absolutely exploded. That 4-cylinder screamer with its boxy flares and aggressive aero became the blueprint for every performance sedan that followed. Fast forward through 5 more generations, and we arrive at today's G80 M3. November 2020 marked a historic moment. Series production began at the very plant where BMW's heart beats strongest, the Munich headquarters. Plant director Robert Engelhorn made a telling observation. The integration of the M3 went absolutely smoothly. We benefited from the vast experience gained with previous generations of BMW M vehicles. That might sound like corporate speak, but it's actually extraordinary. Integrating a 503 horsepower performance sedan into a production line that also builds diesel wagons and plug-in hybrids requires manufacturing gymnastics most automakers wouldn't dare attempt. Yet Munich pulls it off 1,000 times per day. One line, infinite possibilities. Here's where things get genuinely mind-blowing. Walk into any major automotive plant and you'll find dedicated lines for specific models. Performance variants often get separate, slower, more specialized production areas. Not at BMW Group Plant Munich. Every single G23 series variant, the 4-cylinder 330i, the diesel 320d, the plug-in hybrid 330e, the touring wagon, and yes, the M3 Competition with its hand-assembled components, flows through the same flexible production line. We're talking about a system so adaptable that a base sedan can be followed by a $155,000 M3 CS, then a practical diesel wagon, then another competition model, all within minutes of each other. This flexibility isn't just impressive from an engineering standpoint, it's financially brilliant. When global semiconductor shortages hit in 2021, BMW could instantly adjust production ratios. More customers ordering M3s, increased performance car output without retooling. The system reacts to market demands with the agility of a much smaller manufacturer while maintaining the scale of a global powerhouse. Approximately 2,000 robots operate throughout the Munich facility. But unlike fully automated factories, BMW maintains human-robot collaboration zones, critical quality checks, final assembly verification, and those handcrafted components. Those require the human touch, specifically the skilled hands of approximately 8,000 employees representing over 50 nationalities. the art of handcrafted aggression. Now let's talk about what makes the M3 different as it moves down that shared assembly line. And this is where that hand-assembled performance becomes literal. The hood, those sculpted side panels. On a regular 3 Series, robots stamp, press, and install these body panels with millimeter precision in a fully automated process. But the M3? These components are handcrafted and manually assembled by skilled technicians at BMW's in-house body shop. Why? Because the M3's bodywork isn't just about aesthetics. It's functional aerodynamics. Those wider front fenders accommodate the M3's broader track width and massive brakes. The power-domed hood clears the high-performance S58 engine and its heat-generating turbochargers. The side panels integrate functional air breathers behind the front wheels, channeling hot air from the engine bay while reducing front axle lift at high speeds. This manual approach introduces variables that robots hate. Slight material inconsistencies, temperature-related expansion, the need for real-time adjustment. A robot programmed to install a panel within 0.1 millimeters would throw error codes constantly. A skilled technician can feel, adjust, verify, and perfect the fit in ways automation simply cannot replicate. The tolerances here are insane. We're talking about gaps between panels measuring less than 3.5 millimeters, maintained consistently across every hand-installed component. One technician told automotive journalists that fitting an M3 hood properly takes approximately 3 times longer than a standard 3 Series hood. But the result? That signature M3 presence that makes people turn their heads even in a parking lot full of luxury cars. Carbon fiber from aerospace to your roof. While those body panels are being hand-fitted, something extraordinary is happening in another section of the plant. Carbon fiber reinforced plastic roof production. And this process has a fascinating backstory. Until spring 2020, the BMW M3 Coupe was manufactured right here in Munich, pioneering a standalone CFRP roof manufacturing process. When M4 production shifted to BMW's Dingolfing plant, Munich engineers adapted that entire CFRP process for the new M3 sedan. The process begins thousands of miles away. Raw carbon fiber precursor material is sourced from Otek, Japan, then shipped to Moses Lake, Washington, where BMW operates a specialized carbon fiber facility. There, the material undergoes carbonization, heated to extreme temperatures in an oxygen-free environment, burning away everything except pure carbon filaments. These filaments, each strand containing 50,000 individual carbon fibers thinner than a human hair, are wound onto massive spools and shipped to BMW's SGL facility in Wackersdorf, Germany. Advanced weaving machines create carbon fiber fabric sheets with specific weave patterns optimized for strength-to-weight ratios. At Munich, technicians layer these sheets into 5-layer preform blankets, place them into molds matching the M3's roof contours, then load them into an RTM press. Resin is injected under high pressure, and the entire assembly enters an autoclave, essentially a massive pressure cooker that cures the carbon at approximately 248 degrees Fahrenheit for about 2 hours. The result? A roof structure that weighs 50% less than the steel equivalent while providing equal or superior rigidity. This weight reduction, roughly 11 pounds, sits at the absolute highest point of the vehicle, lowering the center of gravity and improving handling dynamics. But here's what really showcases BMW's manufacturing prowess. This entire aerospace-grade carbon fiber process happens on the same production line timeline as every other 3 Series variant, synchronized perfectly to arrive at exactly the right moment on the assembly line, never causing delays or bottlenecks. Seats that take 3 hours to build. Now, while that body is taking shape and that carbon roof is curing, let's visit Munich's most specialized operation, the in-house seat production facility where the M-Carbon bucket seats are born. These aren't your typical car seats. In a regular 3 Series, seats are designed for all-day comfort and broad appeal. The M-Carbon bucket seats are fundamentally different. Designed to hold you in place during sustained 1.0 G lateral cornering forces on a racetrack, the backrest structure is created using the same CFRP processes as that roof. Carbon fiber fabric laid up in molds, resin injected, cured under heat and pressure. But seats introduce challenges that flat panels don't. Compound curves, mounting point reinforcements, integrated structural elements for side impact protection. Pre-production of these carbon seat components requires approximately 3 hours of worker time. For context, a conventional car seat is typically assembled in 15 to 20 minutes. Why so long? Because carbon fiber seat construction involves layup precision that determines not just structural integrity, but also occupant safety in crash scenarios. Once those carbon fiber backrest structures are completed, they enter final assembly, which takes another 2 hours. Technicians install the Alcantara side supports, hand stitch and fit merino leather seating surfaces, integrate seat heating elements, and install electronic adjustment mechanisms. Then comes quality verification. Every single M carbon bucket seat undergoes individual structural testing, comfort verification, electronic system checks, and visual inspection before approval. The rejection rate is higher than standard seats. If even minor defects are found, that seat doesn't make it into an M3, period. When you option these seats, a $3,800 upgrade in the United States, you're paying for 5 hours of specialized labor, aerospace-grade materials, and quality standards that exceed typical automotive components. And these seats significantly increase the M3's resale value, making them one of those rare options that actually returns value. The heart of the beast, S58 engine assembly. While the chassis progresses down the main assembly line, let's head to the powertrain section, because the S58 engine deserves its own spotlight. This is BMW M division's latest masterpiece of internal combustion and potentially one of the last great straight-six turbocharged engines before electrification dominates. The S58 specifications read like enthusiast poetry. 3.0 liters of displacement from an inline-six configuration, twin mono-scroll turbochargers, a 9.3:1 compression ratio, and a 7,200 RPM redline. In standard M3 form, it produces 473 horsepower and 406 pound-feet of torque. But in competition trim, boost pressure increases from 18.9 psi to 24.7 psi, unleashing 503 horsepower at 6,250 RPM and 479 pound-feet of torque from 2,750 RPM, all the way to 5,500 RPM. That torque plateau, nearly 2,800 RPM of flat consistent pulling power, means face-melting acceleration across virtually the entire rev range. The S58's engineers created what feels like naturally aspirated responsiveness with turbocharged force. The engine assembly process reflects this sophistication. The closed-deck aluminum block begins with precision boring of 6 cylinder chambers, measured with laser micrometers to ensure consistent 84 mm diameters with tolerances of 0.01 mm, 1/10 the thickness of a human hair. The forged crankshaft, produced by Mahle and heat-treated for extreme durability, is chrome molybdenum steel engineered to withstand cylinder pressures exceeding 1,500 psi during peak boost. BMW M over-engineers these components significantly, which is why the S58 has become the tuning community's favorite. Stock internals have proven reliable at over 800 horsepower with proper modifications. Forged steel connecting rods are installed next, followed by forged aluminum pistons with Mahle's proprietary anti-friction coating that reduces parasitic friction losses by up to 15%. Free horsepower just from slippery pistons. The cylinder head installation is where things get genuinely advanced. This head incorporates 3D printed metal sections. Yes, in a production engine. Why? Because 3D printing allows engineers to design cooling passages and oil galleries with geometries impossible through traditional casting. improving heat management exactly where turbocharged engines struggle. Variable valve timing and variable valve lift systems are installed, calibrated, and tested. These systems continuously adjust valve timing and lift based on engine speed, load, and temperature, optimizing everything from cold start emissions to high RPM power delivery. Finally, those twin turbochargers are installed with sophisticated wastegate control, allowing independent boost control for each bank of cylinders, improving response and maximizing power output while meeting strict emissions regulations. The completed engine undergoes hot testing, actually running on a dynamometer under load, measuring power output, checking for leaks, verifying proper oil pressure and temperature management. Only engines that pass earn the right to marry with an M3 chassis. xDrive, the first AWD M3 in history. For M3 competition models equipped with xDrive, BMW's first ever all-wheel drive M3, additional components transform this performance sedan. The electronically controlled multi-plate clutch transfer case, front drive shaft, and all-wheel drive control modules create a system that represents a philosophical shift for M Division, which historically championed rear-wheel drive purity. The xDrive system allows drivers to select between four-wheel drive mode, maximum traction, rear-biased power distribution, four-wheel drive sport, even more rear bias for controlled drifts, or full two-wheel drive mode, traditional rear-wheel drive purist fun. The system can fully decouple the front axle for pure RWD driving. The xDrive system adds approximately 90 pounds, but also adds 20 horsepower, 523 horsepower total, and drops the 0 to 60 miles per hour time from 3.8 seconds to 3.2 seconds. That's supercar territory, matching or beating a Corvette Z06 to 60 miles per hour from a four-door sedan. For purists, BMW still offers the standard M3 with rear-wheel drive and a 6-speed manual transmission, the only M3 variant with a manual gearbox, preserving that traditional driver engagement. Paint shop perfection. Before the powertrain marriage happens, every body goes through BMW's paint shop. And for M3s, this process includes M-specific procedures. The Munich paint shop uses a multi-stage process with electrostatic coating baths applying corrosion protection and primer layers. Standard BMW colors use a 3-stage process: base coat, metallic or pearl effect coat, and clear coat. But many M3 buyers opt for BMW individual colors, which add 2 or even 3 additional coats and specialty finishes. Historic M colors command premium prices: $4,500 for BMW individual colors like Laguna Seca Blue, Dakar Yellow, or Imola Red, a triple coat non-metallic requiring special application procedures. These paints aren't just mixed differently, they're applied differently, sometimes requiring additional curing time or special booth temperature settings. After painting, every body undergoes examination in a specialized lighting booth simulating various conditions: bright sunlight, overcast daylight, dusk, artificial light. Inspectors look for orange peel, runs, dust contamination, and any defects larger than 0.5 millimeters. The rejection rate is higher for M models than standard BMWs. The marriage and final assembly. The marriage is where the completed engine, transmission, subframes, differential, suspension, exhaust, and driveline combine into one powertrain module, then unite with the body. In Munich, this happens with balletic precision. The body arrives suspended in the air, tilted at precisely 23 degrees. The complete powertrain module approaches from below on an automated guided vehicle. Robotic arms with vision systems scan reference points on both, calculating exact positioning within 0.5 millimeters. In approximately 90 seconds, dozens of mounting points simultaneously connect. After marriage, the M3 enters final assembly. Front and rear fascias are installed. The M3's front bumper integrates active air flaps that open and close based on cooling demands and speed. The rear bumper incorporates quad exhaust outlets with electronically controlled valves. Wheels and tires arrive mounted and balanced. The M3 Competition runs 275/40 IR, 18 front, and 285/35R 19 rear in staggered fitments for maximum traction. Windows are robotically installed using specialized adhesive that actually contributes to chassis rigidity. Doors, hood, and trunk are installed and adjusted using laser measuring systems to verify panel gaps are consistent. Then, after approximately 18 hours from body in white to completion, this M3 reaches the end of the line, but it's not done yet. Testing. The proof is in the driving. Every M3 undergoes final testing on a dynamometer where it's accelerated to highway speeds while technicians monitor hundreds of data points: engine temperature, transmission shifts, brake operation, all-wheel drive engagement, stability control, steering response, and suspension behavior. The car is then driven on Munich's test track. Yes, the plant has its own circuit where it's subjected to acceleration runs, braking tests, handling evaluations, and noise/vibration/harshness assessments. Finally, water testing in a booth simulating torrential downpour verifies all seals and panel fit-ups are watertight. Why this matters? So why hand-assemble body panels when robots could do it faster? Why spend 3 hours crafting carbon bucket seats? Why integrate a performance car onto a mainstream production line? The answer reveals BMW's fundamental manufacturing philosophy: flexibility without compromise. By integrating M3 production into Munich's flexible assembly line, BMW responds to market demand instantly. When M3 orders surge, production increases without building a separate facility. This flexibility saves millions in capital expenditure. But that flexibility never compromises the M3's special nature. Those handcrafted components, those carbon fiber processes, those specialized seats, these exist because they genuinely improve the product in ways automation cannot yet replicate. This isn't tradition for tradition's sake, it's engineering pragmatism meeting manufacturing artistry. The result is a vehicle that makes 503 horsepower, rockets to 60 miles per hour in 3.4 seconds, handles like it's on rails, and yet can be daily driven in Munich traffic or through Buffalo blizzards. It's a supercar with a back seat. It's a family sedan that dominates racetracks. The legacy continues. That original E30 produced 192 horsepower. Today's G80 competition makes 503 horsepower. The E30 hit 60 miles per hour in about 6.7 seconds. The G80 does it in 3.4, yet both cars share something fundamental. They're hand-built performance machines created by people who genuinely care about the end product. That technician fitting the M3 hood? They know that panel might get photographed thousands of times. That specialist crafting those carbon bucket seats? They understand someone will trust their work during 150 miles per hour Autobahn runs. That engineer programming the engine management, they've fine-tuned it based on countless hours at the Nürburgring Nordschleife. This is why BMW M3s command respect from Porsche 911 owners, admiration from Mercedes AMG enthusiasts, and even grudging acknowledgement from Ferrari drivers. Because behind all the technology, underneath all that carbon fiber, the M3 represents something increasingly rare in modern manufacturing: genuine craftsmanship at scale. Your turn. So here's the question. Knowing what goes into building one of these machines, knowing that human hands still shape critical components, knowing that 35 years of racing heritage flows through every assembly station, does the BMW M3 Competition represent the pinnacle of modern performance sedan engineering, or have competitors like the Mercedes AMG C63, Audi RS5, or even the all-electric newcomers surpassed it? Drop your thoughts in the comments below. Are you Team M3, or is there another performance sedan that deserves this level of manufacturing respect? And if you found this deep dive into BMW's Munich factory fascinating, smash that like button so more automotive enthusiasts can discover what actually goes into building a modern performance car. Share this with the car enthusiast in your life who thinks everything is built by robots now. Subscribe to this channel because we're taking you inside more manufacturing facilities, more engineering deep dives, and more exclusive access to how the cars we love are actually created. Hit that notification bell so you don't miss when we tour Porsche's legendary Stuttgart factory, when we go inside Mercedes-AMG's Affalterbach headquarters, or when we reveal what it takes to build a Lamborghini 512 by hand. Thanks for watching. Now if you'll excuse me, I need to find out where I left my kidney. I think I'm going to need to sell it to afford one of these M3s.